Hi everyone, I hope you're okay. This is the last video, guys, whereby I'm answering question papers, but only the topic of momentum and impulse. Please note that, guys, if this is the video, if this is the first video you come across, there's a playlist there by the description. Just click the link. It will direct you to the playlist whereby you'll find all the answered questions from previous question papers. And the other playlist, guys, is for those who still want to learn momentum and impulse from scratch. So before I even start answering this question, please, guys, don't forget to share this video to your peers. A thing or two that will be mentioned here might be helpful to them. And please don't forget to like, comment, and most importantly, please do subscribe just to help us grow the channel. Thank you very much. Okay. Trolley A of mass 7.2 kilograms moved to the right at a speed of 0.4 meters per second in a straight line on a horizontal floor. It collides with the stationary trolley B of mass 5.3 kilograms. After the collision, the trolleys lock together and move to the right as shown in the diagram below. We must ignore any frictional effect. Okay. Since we're ignoring any frictional effects and there are no forces being applied here, guys, we can simply conclude that we do have an isolated system. Are you together? But before I even start answering here, guys, I want us to declare positive direction. Any movement towards the right is positive. Why am I declaring positive direction? Because momentum is a vector, and whenever you deal with vectors, guys, it's always important to declare your direction. Okay, first question states the principle of conservation of linear momentum in words. It simply states that in an isolated system, the total linear momentum is conserved in both magnitude and direction. And then 4.2.1, we are being asked to calculate the magnitude of the velocity of the trolleys after collision. The velocity of the trolleys after collision. Yeah? Remember that, guys, this is an isolated system. We can simply say that the moment has before is equal to the moment has after the collision. Yeah? Remember that by definition, momentum is the product of the mass of an object and its velocity. Are you together? So the momentum of trolley A would be just the mass of trolley A multiplied by the velocity of trolley A before collision plus the mass of trolley B multiplied by the mass of trolley B before collision is equals to, after collision they become 1 unit. So I'm just going to add their masses and then find the speed at which they are moving at, or the velocity. Okay, the mass is just 7.2 here, and then the velocity is 0.4. Remember that we've declared that any movement towards the right is positive. So I have positive 0.4 there. If something is stationary, guys, it simply means that its velocity is 0, and when the velocity is 0, momentum will also be 0. So I'll have 0 over there, and then I'll add their masses. I have 7.2 plus 5.3. I want to find the final velocity, their combined velocity after collision. 7.2 multiplied by 0.4, I'll simply get 2.88, and 7.2 plus 5.3, I'll simply get 12.5 VF. So therefore final velocity, I'll just divide both sides by 12.5. 2.88 divided by 12.5, you'll simply get to 0.2304. but just round it off to 2 decimal places. 0.23 meters per second to the right. So the magnitude is just 0.23 meters per second. Okay, now we must calculate the average net force. The average net force exerted by trolley A on trolley B during the collision. If the collision time is just 0.02 seconds. Okay, they want us to find the average net force. Ne? Remember that, guys, there's a formula that says F net delta T is equals to change in momentum. Are we together? And then we are looking for this guy. We do have the time. We can find the change in momentum. F net change in momentum can be written as M VF minus VI all over change in time. All right, together. The average net force exerted by body A on body B during the collision. They just want the magnitude, ne? So we can either use body A or we can use body B. It's definitely up to us, ne? Let's go for body B. We have the mass of 5.3 kilograms. The final velocity, that's 0.23. Initial velocity, body B was stationary, so the initial velocity was 0. The contact time is just 0.02. Let's see what we get. 5.3 multiplied by 0.23 minus 0 all over 0.02. We'll simply get 60.95 newtons. So the average net force that OA exerts on B is just 60.95 newtons. So body A is trying to push body B towards the right by this average net force, and body B is trying to do the same thing to push body A towards the left by the same quantity of the average net force. That's how, guys, you're supposed to answer these questions, né? Please, guys, just stay tuned and just know that other videos are coming from other topics as well. So if, guys, there are things you're not sure about, you want to inquire about a lot of things, just ask on the comment section or Bye bye.